Okay, so we're going to continue on with this topic of solving trig equations. We're still in 5.3, except you will see different types of trig equations that involve multiple angles and using inverses. Okay, so you probably have seen multiple angle equations before, and what I mean by that is when you find the vertical asymptotes of a tangent, cotangent, secant, and cosecant, you basically had to solve a multiple angle equation. And so if you take a look at this first example over here, we're asked to find the general solution first, and then of course the solutions on the interval from 0 to 2 pi, non-inclusive for the 2 pi, okay? So the same technique applies, right? If you see a single trig function, right, you want to get it by itself. And so let's do that. So we're going to get sine of 2x is equal to the square root of 3 over 2. Okay, so what do I mean by you've seen multiple equations before, right? The only difference is that the argument is no longer just a single x, and that's why we call it multiple angle equation. It just means there's going to be multiple solutions. And you don't want to divide everything by 2, right? What you really want to do is just do a theta substitution, right? And this is something you've seen me do before in class, right? Call it sine of theta is equal to the square root of 3 over 2. Okay? So if you ask yourself on the unit circle, where is sine positive? It's in quadrants 1 and 2. And theta would have to equal, right, in quadrant 1, it would have to equal pi over 3. And then in quadrant 2, where sine is positive, theta has to equal 2 pi over 3. Okay, so again, that's knowledge of the unit circle, right? Sine of pi over 3 is root 3 over 2. Sine of 2 pi over 3 is also root 3 over 2. Okay, but on part 1, right, we're asked to find the general solution. So over here, right, the distance between pi over 3 and 2 pi over 3 is not by a constant, right? If I were to draw this out, right, here's pi over 3, right, here's 2 pi over 3. Right, the distance between here and here is not always going to be the same as I go around the circle. Okay, so you can't really condense the solution, only if it differs by pi radians. Okay, so for pi over 3, right, I could write plus 2 pi n for the general solution. For 2 pi over 3, I could also write plus 2 pi n. Okay, now this would be correct if we're solving for theta, right? But a lot of times students forget to plug in theta as 2x. So make sure you substitute 2x back into here for theta. And then complete this problem, right? Divide both sides by 2. You're going to get x is pi over 6. The 1/2 is going to cancel out with this. You're going to get x is equal to pi over 6 plus pi n. And then over here, again, do a theta substitution where theta is 2x. Or I guess resubstitute your theta as 2x, right? And this solution will yield x is equal to pi over 3, right, plus pi n. Okay, so divide both sides by 2, right? These 2's are going to cancel out. This 2 is going to cancel out. You're going to have this as the general solution of this problem. Okay, so there's part 1. And then for part 2, right, the way I would do this to get the specified solutions on the interval from 0 to 2 pi is just start plugging in n values. Okay, so if you plug in n as 0 over here, right, 0 plus pi over 6, it's just pi over 6. That still falls in the interval. If you plug in n is equal to 1, you're going to have 6 pi over 6 plus pi over 6, which is 7 pi over 6. Right, if you plug in n is equal to 2, right, 2 pi plus pi over 6, that's going to fall outside of this interval. So n is equal to 2 is not going to work, right? Likewise, if you started with -1, right, it's also going to be outside this interval. So we're done here. And then do the exact same thing. Start plugging in with n is equal to 0. 0 plus pi over 3 is just pi over 3. Again, we're still in that interval from 0 to 2 pi. Plug in n is equal to 1, right? 3 pi over 3 plus pi over 3 is 4 pi over 3. And if you try to plug in n is equal to 2, right? 2 pi plus pi over 3 is going to go outside this interval. So these are my specified solutions on this interval. Okay, so it's always easier to write the general solution first, and then to get the specified solution, just plug in n values until you fall outside of 0 to 2 pi. Okay, so again, this is called the multiple angle equation because there's an argument that's, it's not just x, okay? So if you have like 2x plus 1, 3x, whatever, that's called the multiple angle equation. You're going to get multiple solutions. Okay, so I'm going to move on to example 2 over here. I had it here, but I kind of erased it. Example 2 is going to, you can kind of see it right here, right? Is tangent squared x, sorry, tangent squared 3x is equal to 3. Again, it's a multiple angle equation, right? This argument is a number other than just x or theta. And so let's do a theta substitution. Let this guy be called theta. And we have tangent squared of theta is equal to 3. Okay, so remember your square root equation skills from the last video, right? You take the square root of both sides. And if you take the square root of both sides, right, you're going to get tangent of theta, right, is equal to positive square root of 3. Or tangent of theta is equal to negative square root of 3. Okay, so now I have to remember my unit circle, right? Where is theta, the tangent of theta equals positive root 3? Well, let's take a look over here on our unit circle, right? For at pi over 3 radians, this value right here is 1/2 comma root 3 over 2. So if I take the tangent of pi over 3, the ratio of y over x, root 3 over 2, divided by 1/2, right, will just give me square root of 3. Okay, so tangent of theta, where is it, root 3? It's any combination of pi over 3 in my unit circle, okay? So my theta right here is going to be pi over 3, where tangent is positive. Now tangent is also positive in quadrant number 3, right? 1, 2, 3, tangent is positive. Quadrant 1, quadrant 3. And the radian value in this quadrant, right, would be 4 pi over 3. Okay, so moving on for where tangent is negative. Tangent is clearly negative in quadrant 2 and quadrant 4. And so it's going to be any value over 3, right? Pi over 3. So in quadrant 2, right, theta is going to be 2 pi over 3. And theta for quadrant where it's negative for quadrant 4 is going to be 5 pi over 3. Okay, so that's just a little unit circle stuff. And remember, we're doing part 1 here, right? We want the general solution. Before we write, oh, plus 2 pi n plus 2 pi n, notice the distance between pi over 3 and this guy right here is 4 pi over 3, right, is a full pi, right? And so I can condense these two solutions by saying, hey, this is just theta is equal to pi over 3 plus pi n. And the distance between, you know, if I had 2 pi over 3 over here, right, and this guy right here was 5 pi over 3, this distance is also a full pi, right? Go around here, it's pi. Go around here, it's pi. It has to be equal distance, okay, for you to condense the solution. So over here, I could say theta is equal to 2 pi over 3 plus pi n. Oops. Okay, so remember, we're not solving for theta, right? We're solving actually for x. So you can now do a substitution for x. And the other thing what I'm going to do is I'm going to combine these two fractions, right? If I multiply this guy by 3 over 3 on the right side, right, I'll get 3 pi n over 3. Okay, all I did was multiply this guy with 3 over 3, so I'm adding these two expressions. And then do that theta substitution, right? Theta is equal to 3x. Okay, so I'm almost done with this part right here. Pi plus 3 pi n over 9, if I divide both sides by 3. And then do the exact same thing over here, right? Maybe combine these two fractions. This would be 2 pi plus 3 pi n over 3. Okay, so again, don't combine these. These are not like terms. Okay, there's an n over here. And then set this equal to 3x because theta, remember, is 3x. And over here, you're going to get x is 2 pi plus 3 pi n over 9. Okay, so these would be the general solutions to this problem. The only tricky part right here, right, is of course doing that theta substitution and then also condensing these solutions, right? I gave you, if you didn't quite get that condensing part, I did explain it in the other video, so you might want to go back and take a look. And these are the general solutions. Okay, but we're almost done with this problem, right? We still have to find the specified solutions on the interval from 0 to 2 pi. So this is where combining the fractions makes it a little bit easier to compute. So if you remember how I did it on the previous example, right? All I did was start plugging in n values. And so for the first n value I'm going to plug in is n is equal to 0, right? So if I plug in n is equal to 0, I'm going to have 0 plus pi, which is pi. I'm going to have pi over 9. So that falls under the interval from 0 to 2 pi. N is equal to 1. I'm going to get 3 pi plus pi, which is 4 pi over 4 pi over 9. Plug in n is equal to 2, right? 6 pi plus 1 pi is 7 pi over 9. Plug in n is equal to 3, right? 9 plus 1, that's 10 pi over 9. N is equal to 4. 12 plus 1, that's 13 pi over 9. N is equal to 5. 15 plus 1, that's 16 pi over 9. And you're like, is that still in the interval? Well, 16 over 9, that's 1 and 7 ninths. 1 and 7 ninths pi is still under 2 pi, right? All right, now if you plug in n is equal to 6, right, look what happens. 3 times 6 is 18. 18 plus 1, that's 19 pi over 9. And if you think about this number right here, right, this is 2 and 1/9 pi, which falls outside of 2 pi, right? We don't want to go 2 and 1/9 pi. So this answer is not going to be in that interval. You're only going to get 6 solutions, 1, 2, 3, 4, 5, 6 for this general solution, right? But we're still not done yet, right? We also know there's solutions that are part of this answer right here. So do the exact same thing, right? Plug in n is equal to 0. 0, you're going to get 2 pi over 9. If you plug in n is equal to 1, you're going to get 5 pi over 9. If you plug in n is equal to 2, 6 plus 2, that's 8. 8 pi over 9. And so forth, right? Plug in n is equal to 3. 9 plus 2 is 11. N is equal to 4. You're going to get 12. 12 plus 2, that's 14 pi over 9. N is equal to 5. 15 plus 2, that's 17 pi over 9. And you're like, okay, 17 pi over 9, that's still 1 and 8 ninths, right? So you're still good. Now, if you plug in n is equal to 6, right? 18 plus 2, that's 20 pi over 9. Now, 20 pi over 9, that's 2 and 2/9 pi, right? Again, this falls outside the interval. So the only answer that you're going to get up to is n is equal to 5, okay? So take a look. There's 2, 4, 6, 8, 10, 12 total solutions that fall under this interval from 0 to 2 pi. And my suggestion when you're doing these multiple angle equations is always come up with the general solution first and then get the specified solutions on the interval by plugging in n values. Because if you did this first, right, it'd be kind of hard to think about it unless you had the general solution.